in this section, it's important that you know the terminology. So just let's start here. Like if I write f of t, this means f is a function of t, and t is independent, and f depends on t. F depends on t, so f is dependent. G of x. G is a function of x. So when you write out your expression, it only has x's in it. And above, when you write out the expression, it only has t's in it. And you could keep going. You could say z of y. Z is a function of y. So when you take the derivatives, this would be df dt. This would be dg dx. This would be dz dy. So we learn how to take a derivative of functions where it's just not y equals something, y equals an expression. And this is called implicit differentiation. Alright, so let's just start with an example. Suppose I have x squared plus y squared equals 4. Now that's not a function because that's a circle with radius 2. X squared plus y squared equals k squared is a circle. Now we want to take the derivative. So the old way, or the way we know, is to solve for y and get it to be y equals. And that would be y equals plus or minus the square root of 4 minus x squared. So let's just take the positive one, just for this example. So dy dx, or y prime, would be the derivative of 4 minus x squared to the 1/2 prime. And that's using the superpower rule. We'd bring the 1/2 down, leave the inside alone, subtract 1 from the exponent, come back, take the derivative of the inside. So we have minus x over the square root of 4 minus x squared. Okay, now, implicitly means that y is still a function of x, but the problem is that it's mixed up with the x's. So when we take the derivative of x, x is independent, so we just have dx dx, we're taking it with respect to x, and that's going to be 1 just like normal. When we take the derivative of y, we get dy dx. Okay, and we have to use the chain rule when we take derivatives here, along with the product rule and quotient rule sometimes. Okay, so we start out with x squared plus y squared equals 4, but now we're not going to solve for y or x, we're just going to take it as it is. So when we take the derivative of x squared, we're taking the derivative with respect to x, so we have dx in the denominator. That's going to be the chain rule, so I bring the 2 down, leave the inside alone, subtract 1, so that's 1. Come back, take the derivative of x, which is dx dx, or 1. Okay, so that's normal, because we know the derivative of x squared is 2x. dx dx is 1. Take the derivative of y squared. Well, that's going to be, bring the 2 down, that's the chain rule. Leave the inside alone, subtract 1, come back, take the derivative of the inside. This time it's dy dx. Take the derivative of y with respect to x. So you have to keep in mind in these problems that y depends on x. Y is really y of x, and that's the most important thing you can remember when you're dealing with this section. When you see a y, it's really y of x. Alright, so that simplifies to 2y. Let's just write it as y prime. and then the derivative of 4 is 0. Now when we solve for y prime, we have y prime equals minus 2x, and then, well, 2y, and then y prime equals minus 2x over 2y, which is minus x over y. Now does that right there look anything like our other answer? Remember, our answer is this in terms of x. Here we have an answer in terms of x and y. But yeah, that's the same, because remember what y is equal to. Remember up here we solved for y. Okay, let's go back. And we took the plus. So y is equal to the square root of 4 minus x squared. We'll substitute that back in, because this really is the same problem. As I can. Okay, so that's equal to minus x over, remember what y was? 4 minus x squared. So this checks with the old way of doing it. But here's the problem. You can't always solve for y. Sometimes y is so embedded in the problem that you can't get at it. So this is when we use implicit differentiation. So again, the most important thing to remember when you're doing this is that y prime is dy dx, and x prime is dx dx. And we use the chain rule. So another thing is helpful to remember, that if you're doing the derivative of y squared, using the chain rule, that brings the 2 down, leaves the inside alone, subtract 1, come back and take the derivative of the inside, which is dy dx. So every time you take the derivative of y, you need a dy dx. And that'll save you a lot of headaches, if you remember that. Okay. A function is implicit, or an implicit function, if when the function is replaced for y, the equation is an identity. That means it's always equal. So, for an example, you have x squared plus y squared equals 4. We have y equal plus or minus the square root of 4 minus x squared. And if we take that and plug that in here, we get x squared plus 4 minus x squared equals 4. We get 4 equals 4. That's an identity. So when you solve for y, if you can, and substitute it back in, then we say that's implicit function. But again, sometimes it's really, really difficult to solve for y, so we're not going to do it that way. We're going to not solve for y and just go ahead and take the derivative along the way. So we're going to take the derivative of each term separately and then solve for y prime. So you ready? Okay. Take the derivative of y to the fourth. Now, every time you take the derivative of y, you need a y prime. So the derivative of y to the fourth is bring the 4 down, leave the inside alone, subtract 1, come back, take the derivative of y. Now that's the part that you're going to forget to do, so don't forget. And again, this is the superpower rule, where you bring the exponent down. Let me do that in red. Bring the power down, leave the inside alone, subtract 1 from the exponent, come back, take the derivative of the inside. Superpower rule. Plus, derivative of 3y. Derivative 3 is a constant, so that just stays out front. Derivative of y, dy dx. Okay, derivative of y is not 1. It's y prime because y depends on x. Remember, you have to keep in mind y is really y of x. Y depends on x. Okay, so that's that. Minus. Okay, we're going to use the superpower rule again. Bring the constant 4 just stays out in front. Bring the 3 down, so that's 12. 4 times 3 is 12. Leave the inside alone. Subtract 1. Come back. Take the derivative of x, dx, dx, or 1. I always like to put the dx's in there because every single term is going to have a dx if you did it right. Okay, equals derivative of 5x is 5 dx dx, derivative of 1 is 0. So what I'm saying is if you do it this way, it's not quite the same as the book does it, but if you do it this way, you can go back and check that every term has a dx in the denominator, and that tells you you're doing it right. If you don't have that, then you're not doing it right. You're forgetting something. All right, let's go and see what happens. Again, let me go back to superpower. We'll bring the 3 down, bring the exponent down, leave the x alone, subtract 1 from the exponent, come back, take the derivative of the inside. Okay, let's change this to y prime. Dx dx is 1. So we're solving for y prime. What you're going to do is factor out y prime. The steps are always the same, because you want to get it by itself. You take everything that doesn't have a y prime over to the other side, and now we just divide. And that's our final answer. And you can leave y's in the answer. That's the beauty of this, is that you can't really solve for y, so there's going to be y's left in your answer. Try another one. This takes a lot of practice, because if you forget one y prime, the whole thing's going to be wrong. Okay, derivative of x. We just go down the line and take the derivative. It's dx dx. Now you have to notice here, it's x times y, so we're going to have to use the product rule. So all these rules are going to come into play here. You have to recognize that. Okay, so the 2 is going to stay out in front. The product rule is the first times derivative of the second plus the second times derivative of the first. Again, it doesn't matter what order you do this in. So it's the first times the derivative of the second. Derivative of y is dy dx plus the second derivative of x is dx dx. And if you just stop and think about each step instead of trying to rush through the problem, it's not difficult to do. You just have to go slow. Okay, derivative of y cubed. Again, that's a superpower rule. Bring the 3 down, leave the inside alone, subtract 1, come back, take the derivative of the inside. If you say that each time, it's going to make it so much easier on yourself. Derivative of 1 is 0. Okay, now again, notice I have dx every step of the way. In every term, I have a dx, so I know I'm pretty sure I did it right. Okay, again, that doesn't guarantee it, but you're pretty sure. Now I can go back and simplify it. That's 1 minus 2xy prime minus 2y dx dx is 1 plus 3y squared y prime equals 0. And do that. So make sure that you do this step. That will save you a lot of headaches. Again, check for dx in each term. Every term should have a dx in it if you do it this way. Also, the big deal here was that you had to look and make sure you saw that that was a product. You have to use the product rule. Okay, now I'm going to factor out a y prime from here and here. And take everything that doesn't have a y prime onto the other side, and then I divide. So again, the steps are the same. Factor out y prime. Take everything over that doesn't have a y prime, so that's going to go the other side, that's going to go the other side, and then I divide. Okay, let's look at one more. Well, maybe a couple more. Let's do x squared cosine y minus 2 equals 0. Again, you have to notice, what is that? Well, that's product. So make sure you take a careful look at the problem before you start. So it's the first times the derivative of the second. Derivative of cosine is minus sine y, but you have to come back, use the chain rule, and take the derivative of the inside. Okay, that's the chain rule. Plus second times the derivative of the first, which is 2x. Bring the power down, leave the inside alone, subtract 1, come back, take the derivative of the inside. Again, that's the superpower rule. Derivative of negative 2 is 0, so that's just equal to 0. Simplify it. Dx is 1. Y prime is going to be minus 2x cosine y divided by minus x squared sine y, and that's going to be 2 cosine y. The x's cancel and the negatives cancel. Sine y, or 2 cotangent y over x. Okay. Let's just keep practicing. Okay, here you're going to use the superpower rule. Bring the 2 down. Leave the inside alone. Subtract 1 from the exponent. Come back, take the derivative of the inside. That's going to be 2x dx plus 2y dy dx. On the other side, I have 2x dx minus 2y dy. There's no product rule, quotient rule, or anything like that. It's all the superpower rule and the chain rule. So multiplying this out, I'm going to get a 4x cubed plus 4xy squared plus 4x squared y prime plus 4y cubed y prime equals 2x minus 2y y prime. I get all the y prime terms together on one side, and I factor it out. So I bring this over, that's going to change to a plus. That's going to stay here. This is going to go over, that's going to go over. Divide, and you're done. Okay, let's find the slope of the tangent line at x equal 1 for square root of x plus square root of y equal 3. Okay, so we're going to do this implicitly. That's x to the 1/2 plus y to the 1/2 equal 3. Taking the derivative, that's going to be a half x, subtract 1, come back, take the derivative of the inside. Bring the power down, leave the inside alone, subtract 1, come back, take the derivative of the inside. Derivative of 3 is 0. So I have 1 over 2 square root of x plus 1 over 2 square root of y prime equals 0. At this point, I'm just going to substitute the numbers in. Okay, let's go back here. If x is 1, then I have square root of 1 and it's 1, plus square root of y equals 3. I have square root of y equals 3 minus 1 is 2, so y is equal to 4 when I square both sides. So the point I have there is 1, 4. So you have to find the y value. So I can substitute it back in here. To get y prime, because that's the slope of the tangent line. So this is going to be 1/2 plus 1/4 y prime equals 0. 1/4 y prime equals minus 1/2 y prime equals minus 2. So that's your slope of your tangent line, -2. Okay. Let's try one more. Again, the more you practice this, the easier it gets. Find the horizontal tangent line to x squared. Let's just find the x value. Okay, here you have to notice, take your time and look, and that's the quotient rule. So we have the denominator times the derivative of the numerator. Derivative of y is dy dx minus the numerator times the derivative of the denominator over the denominator squared. And the derivative on the right-hand side of y is dy dx. Okay, so I have 2x squared plus xy prime minus x squared minus y equal x squared y prime. And then multiply both sides by x squared to get it out of the denominator. So I'm going to take that, multiply both sides by x squared. Get all the y primes together and factor. Take everything else to the other side. Actually, 2x squared minus x squared is x squared, so I take that to the other side, and I take this to the other side, so I have plus y. So y prime is minus x squared plus y over x minus x squared. So the horizontal tangent line happens when the slope is 0 or y prime is equal to 0. And that only happens when your numerator is 0. So this happens when y equals x squared. You're going to have a horizontal tangent line. See, when you have a fraction, the denominator can be anything, and that's equal to 0. So you just set your numerator equal to 0 when you want to take the when you want to set a fraction equal to 0. Okay, we'll look at some of the example homework problems.